this activity
That's called the reverse shell. And in the next few minutes, I'll show you exactly how it works using Netcat for both Linux and for Windows. So now normally, you can't just connect to another machine. Firewalls are designed to block incoming connections, so if I try to reach into the target, the connection usually gets dropped. But those same firewalls usually allow outbound traffic because that's how you browse the web, download updates, or connect to online services. And that's exactly what we're going to try to do. So instead of trying to reach the target, we make the target reach us. That's all reverse shell really is. The target initiates the connection, and because it looks like a normal outbound traffic, the firewall often allows it. And so to catch that connection, I'm using Netcat. It's a lightweight networking utility that has been around since the 90s, and it's still one of the most useful tools for working with TCP and UDP connections. Okay, now let's demonstrate it. The first thing I need is a listener. I'm telling Netcat to listen for incoming connections. -L puts it into listening mode. V gives me a variable's output. N skips DNS lookups. And P specifies the port. In this case, I'm using port 4444. And now it's just waiting for something to connect. Now, for the Linux example, I'm actually using an offensive security practice machine. Earlier, I found a vulnerability in this application, and now I'm going to use it. That runs on the target and tells it to call back to my machine. That's why I already have Netcat listening. The exploit creates the outbound connection, and Netcat is there waiting to catch it. Think of it like leaving your phone number with someone. Instead of me trying to force my way in, the exploit tells the target to call me, and Netcat is waiting to answer. The same concept applies here with Windows. For this demo, I'm using PowerShell from my own Windows machine to connect back to my Kali listener. The plain text version of the command was messy because PowerShell kept finding the quotes, variables, and special characters. So I encoded the command into base64 and passed it to PowerShell that way. This doesn't make it encrypted or hidden, it's just another way of formatting the same command so PowerShell can interpret it correctly. And there it is, Windows connected back to my listener. Now I'm interacting with the Windows machine from Kali Linux. The whoami command output shows the Windows user, which is me, shows the host name, confers the machine name, and pwd shows the current directory on the Windows system. This is running in my own lab environment, so this time it's not an actual practice machine. This is from my own lab environment. I would recommend to not run it against systems that you don't own or have permission to test. Full disclaimer, by the way, don't do it. Whether it starts from an exploit, a phishing email, malware, or a malicious document, the objective is often the same. Get the target to connect back to the attack. If you're doing CTFs, hack the box, or studying for the OSCP, reverse shells are basically your best friend. If you can get one, you're usually having a pretty good day. This demonstration also worked cleanly. These machines don't have an endpoint detection or active monitoring. On a real corporate network, or even in private machines, this exact activity will get you detected right away. So that's a reverse shell. Instead of breaking through the firewall, the target simply connects back to you, and Netcat makes it easy to catch that connection. If you're following along, try it on your own lab and only on systems that you own or have permissions to test. Thanks for watching. Stay tuned. The next one's going to be very interesting. Stick around. Bye-bye. Peace. Peace. Damn right, this is my lighting. I'm a Jedi. Peace out.